All right, so section 1.7 is exponents, okay, and order of operation. So exponents are just repeated multiplication. So when we learned about multiplication, I told you it's just repeated addition. Instead of adding 2 9 times, a quick and concise way was 2 times 9, right? So on all these, look how monotonous it is, times 4, times 4, times 4. That's really annoying to write. So what's a quick and precise way to write that? Exponents. And what exponents are, they're little numbers that go up as a superscript, okay? So these first things aren't even us having to solve the actual math. They just want us to show, can you write it in exponential form, all right? So let's write it in exponential form, and then I'll kind of label the parts. So whatever you're multiplying multiple times is called the base. So on A, what are we multiplying a lot? The number 8. So that's called the base. How many times did we multiply 8? 4 times. So that means our exponent needs to be a little 4 up here. 8 to the 4th power, absolutely. 4th power is called your exponent or power. Notice he's little, okay? Which means he's an exponent. If I wanted 8 times 4, I'd have 8 times a big 4. Keep that in mind. Because a lot of people on the test, when I ask what is 8 to the 4th power, they do 8 times 4 and say 32. No. Why would I make that 4 little if I just wanted 8 times 4? Okay, so keep in mind it's little for a reason because it's a different notation. How do we do number 2? 3 to the 3rd. 3, the big 3, the base, because it's the number 3 we're multiplying. 3, the little exponent y. How many times did we multiply 3? 3 times. All right. What about number 3? 10 to the, what'd you say? Perfect. Why? Because we multiplied the number 10 by itself. How many times? 5 times. All right, so 4 is a little bit interesting because they show you multiple numbers, but you can write both numbers as exponents and just a little dot for multiplication in between. So start with the first. What number are we multiplying first? 5. How many times? So we have it like that. Is that okay? And then times what number? 4. And how many times did we multiply 4? 6 times. So 1 through 4 are not even having to solve. Notice it just says write using exponential notation. So they don't even want us to solve what 5 squared times 4 to the 6 is. They just want us to be able to write it concisely. When you go to do your homework on My Math Lab, they have an exponential button in that little key thing that pops up, or the caret button on your keyboard will pop you up into the exponent. My word of warning, though, is make sure you arrow to the right after you do that. Otherwise, you're still up in la-la land. You're still typing. Does that make sense? So, like, here, when you have to write back-to-back, you type 5, caret 2, arrow to the right to come back down to write your times for caret 6. Because if you don't arrow to the right to come back down, when you type times 4 to the 6, he'll all be up in that little exponent bar, and you'll just be like cussing out the computer. And I can show you, if you're not too sure what I'm saying, I'll show you before the end of class today what I'm talking about there. Okay? All right, so when it says evaluate, what are they asking you to do? Actually solve, right? And I think the reason why they don't use solve is because you're not really solving a problem. Evaluate just means tell me what that number actually is. So then you just work backwards. What does 4 squared mean? 4 times 4. What is 4 times 4? 16, okay? So again, if you can show me you know it's 4 times 4, you'll get partial credit. Because say you know it's 4 times 4, but for some reason you said 4 times 4 was 20, and you just put 20 down. I'm like, I know 20 is not right. You're going to get miss all the points. But if you do 4 times 4 equals 20, you're showing me you know the exponent, but you just didn't know what 4 times 4 was, okay? So every little bit helps. What about 7 to the 3rd power? What is that? Oh gosh, this is getting difficult, okay? So how do I do this? I just take 2 at a time, like I'll do the first 2, okay? So over here, what's 7 times 7? Not 14, 49, because we're multiplying, right? So 7 times 7 is 49, but what do I still need to do to 49? Multiply by another 7. So I'm doing that off. I can't do it horizontally. I'm a math teacher, and I still can't do it horizontally. I'm doing it over here in my scratch work zone, okay? So I know 49 came from the first two 7s, but I still need to multiply by one more 7. Again, lattice, repeated addition, whatever you need to do. If somebody's like, I'm just going to add another 7 to it or whatever, you can do that, or another 49 to that. You can. So 7 times 9 is 63. 4 times 7 is 28. So was that 334? Did you guys get 343 there? Okay. So don't think you have to multiply all 3 in a row and know what's going on. I can't even do that. I'll just do the first 2, then add 1, then add 1, and then add 1. Okay. This is kind of interesting. It's like they're trying to trick you. But what's your exponent there? 1. So what does that just mean? 11 1 times. So that's just 11. So any number to the first power, guys, is just going to be that number because it just means times itself once. What about 2 times 3 to the second? Let's write it out first. What is that?
2 times 3 times 3.
Okay. So this is a great example of what we learned on Tuesday about commutative property. It doesn't matter which way you multiply. In associative property, which ones you do first? So do you like 3 times 3 is 9, times 2 is 18? Or do you like 2 times 3 is 6, times 3 is 18? You see what I'm doing, guys? It doesn't matter which 2 I decide to multiply first. Just make sure you're multiplying by 3 numbers, okay? Or is anybody like me where we kind of just like to move left to right? Anybody like that? So if you're going to move left to right, you'll do 2 times 3 is 6, times 3 is 18. Did anybody want to do the 3 times 3 first and then double it? Because multiplying by 2 is not that bad. And so any way you do it. So we can do 2 times 3 is 6 times another 3, guys. This is 18. 11, 343, 16. Is that okay? How many of you guys have seen exponents before? A good handful of you, okay? Some of us are seeing it for the first time. So again, I just ask yourself, let's just try to be have courtesy to those that are learning this. All right, order of operations. How many of you guys have heard the term PEMDAS? PEMDAS. Please excuse my dear Aunt Sally, right? It's just a silly acronym to help you remember the order of operations. Did you guys have heard of, what's the other one for the planets? My very educated mother just served me 9 pizzas. But then Pluto got taken out, so my very educated mother just served me nachos. Because you couldn't do that. It's just these silly acronyms to help you remember the order to do things. All right, so these are typed up. Perform all operations with parentheses first. That's the P in PEMDAS, okay? But realize parentheses can be normal parentheses. They can be squiggly brackets, or they can be other grouping symbols, except, for example, a big fraction bar, like a big division bar, means do the top first before you do all the other stuff. So that's the P. Evaluate any expression with X, so parentheses the P, exponent second, so that's your E for PEMDAS, all right? Multiplication and division, that's the MD. But notice it's always left to right. So just because M comes first in PEMDAS, multiplication and division are actually tied. So if you see both, you need to move left to right. Exactly the same with addition and subtraction. That's where the as comes from, addition and subtraction, but you need to do it left to right. So if all it is plus minus, plus minus, plus minus, you don't do the pluses first, you move left to right, okay? So just always know addition and subtraction, always the last thing you do. Everything else has an order before that. Okay, so let's try to do these bad boys on the next page. So I'm going to write PEMDAS up here so it reminds me. Please excuse my dear Aunt Sally. Does anybody have an Aunt Sally? Because that would be really cool if you did. No? Okay. So, on this first example, example 3, or 9, we're already to 9 already, guys. Are there any parentheses that we have to handle? Are there any exponents we have to handle? No. Is there multiplication or division? Yes. And just because this multiplication is first is why we're doing it first, not because it's multiplication. Does that make sense? So we're going to do this multiplication first. What do you guys get when you do 9 times 3? 27. And then what are we going to do after we do multiplication?
Division.
Division. It's hard to tell, but that is a division symbol, guys. What's 8 divided by 4? 2. And who's in between them? A subtraction. What's always the last thing you do? Either subtraction or addition. What's 27 minus 2? 25, okay? Some of you can just do it horizontally, but a lot of times, guys, even though it's given to you horizontally, I'm going off to the side and doing, you know, like vertical stuff like this if I need to, okay? Or multiplication, like a lattice. If you need to do lattice for 9 times 3 or whatever, feel free to do it. So do we get 25 there as our answer? Is that okay? What's cool is calculators. I know you don't get to use calculators right now, but a lot of calculators know order of operations. And so if you type 9 times 3 minus 8 divided by 4 in your calculator just like that, it will know to do, and you should get 25 on that. All right, next one. Any parentheses that we need to do first? No. What about an exponent? Yes. You guys see that? We have this little guy right here. What does 2 to the second power mean? I'm going to just write that. Okay, so 48 divided by 3 is staying, and we're still multiplying, but we're not going to multiply by 2 squared because we know what 2 squared is. What is 2 squared? 4. So do you guys see how all I did was write the exact same expression, but I did my first operation, 2 squared. Do you see that? We haven't touched 48 divided by 3 yet. We're still multiplying by whatever this is, but 2 squared is 4. All right, now what do you notice? We have multiplication and division. You want to do multiplication first because of PEMDAS? No, they are tied. So what are we going to do? Left to right, okay? So we're going to move left to right. So we need to do 48 divided by 3 first. I know that off the top of my head, but I'm a math teacher. If you don't, go off to the side and figure out what 48 divided by 3 is. How many times does 3 go into 4? 1 time. 3 times 1 is 3. You have 1, carry down your 8. How many times does 3 go into 18? 6. And you guys agree that goes in perfectly? So where are we going to put 16? Instead of rewriting 48 divided by 3, we now know what 48 divided by 3 is. It's 16. But who's still tagging along behind it? Times 4. We know that's 16, and then we're going to do times 4. Do you guys see what I'm doing? Like every layer, I'm doing 1 step, okay? Until I get all my steps done. So what's the last thing I need to do? Multiply. Does anybody know 16 times 4 off the top of their head? If you do, great. 60. I know what you guys. If not, go off to the side and do 16 times 4 over here. 4 times 6 is 24. Put your 4, carry your 2. 4 times 1 is 4, plus 2 is 6, 64. So we took care of the square first. 2 squared was 4. Then we took care of the division next. 48 divided by 13, 16. And we did multiplication last. 16 times 4 is 64. Do you see, like, each layer I'm doing an extra step, but I'm not doing all of it at once. Are there any questions on 10? All right, let's look at 11. This is getting crazy over here. Are there parentheses this time? Yes. And so what do parentheses mean? They mean do the inside first and leave everything else the same, okay? So what's on the inside? 10 minus 7. What is 10 minus 7? 3, right? So this is going to be 3, but what can't we forget's on the outside? 4. To the 4th. Plus 2 times 3 squared. Why did I keep my parentheses there? Because if that was a negative, -3 would be part of that 4th power, and that would give us a different answer if we didn't put the parentheses there, okay? But since it's a positive 3, I don't really need it there, okay? PEMDAS, we took care of the P, the parentheses first. What's the E stand for? Exponents. Do you guys agree that we have 2 exponents going on? So off to the side, let's figure out what 3 to the 4th is and 3 to the 2nd. This is my shortcut for you over here. Instead of multiplying 2 or 3 times, what's 3 times 3? 9. What's 9 times 9? 81. Do you guys see that shortcut? When it comes to multiplying by 4s, I just do the first 2 and the second 2 and then multiply in the middle. Do you have to do it that way? No. You could do 3 times 3 and get 9. Multiply by the third 3 and get 27. multiply by the fourth 3, and get 81, okay? So again, just because I'm showing you this way does not mean it's the only way. I just like to show you a little bit of tricks and shortcuts, all right? So 3 to the fourth is 81. 3 squared is what? 3 times 3, but what is that? 9, okay? Because I need to take care of this exponent here, and I want to be able to put something there as well, okay? So what's my next step? I'm going to write this exact same expression, but I'm going to put in what we know 3 to the fourth is. What is 3 to the fourth? 81. Have we done anything with the plus 2 times? Nope. But what is 3 to the second? 9. So right now we have 81 plus 2 times 9. What's the next move I'm going to make? 2 times 9. Why? Multiplication comes before addition. Addition and subtraction, always the last thing. So 81 is going to hang out as we take 2 times 9. But what's 2 times 9? 18. Say you don't know it, go add up 9 twice off to the side if you need to, okay? Do whatever you need to do to get that answer 18. Last but not least, again, I can add this horizontally. You might not be able to. Throw 81 plus 18 over here to the side and add them up. What do we get? 99. Is that what you guys got? I know you don't think this way, but I think it's really, really cool. This is a completely other way to write 99. So if you wanted to be a smart, you know what, and the answer on a test was 99, technically, you could write 99 like that. Who's going to take their time and do that? Hopefully you don't do that. But that's what's crazy, guys, is that we are writing two numbers 2 different ways. Okay? But every step of the way, guess what this whole expression was equal to? 99. Guess what this whole expression equal was to? It was 99. Guess what this expression was equal to? 99. Every one of these rows was a different way of writing 99. Kind of cool. You're like, no, not at all. Okay. I know how you guys think. All right, 12. Oh my gosh. How can we make these more complicated? All right. So, PEMDAS says take care of parentheses first. We actually kind of have 2 sets of parentheses there, right? And when they start doing 2 steps, guys, they don't do parenthesis on top of parenthesis, so they have to start using brackets, okay? So we look in here, and we're supposed to be doing this math first. So 36 divided by is going to stay as is. But what do you notice inside those parentheses is another set of parentheses, okay? So the very first thing we're going to do is 4 times 2, okay? So the 20 minus is going to hang out as we figure out what 4 times 2 is. What is 4 times 2? 8. Notice I wrote everything else exactly the same, okay? We still have the 36 divided by on the outside. We still have the 20 minus on the inside, but I did my very first operation, that 4 times 2, broke away that first set of parentheses, okay? I still have 4 cubed minus 6 on the outside. So this was number 1, right? What's step number 2?
Subtraction.
The next bracket, right? Because that's still technically parentheses. So this is step number 2, 20 minus 8. Say you don't know it off the top of your head, come over here and do 20 minus 8 off the side. Borrow from the 2. What's 10 minus 8? 2, 1. It's 12, okay? So what is 20 minus 8? 12. So I'm going to write this exact same expression, but instead of writing this ugly chunk right here, guys, I'm going to write 12, okay? So I have 36 divided by 12 plus 4 to the third minus 6. And that's a dividing. I know I'm getting a little sloppy there, okay? So each row, do you have to be, like if you feel really confident and you don't feel like you have to do it step by step, that's fine. You just have to be careful because if you get too confident and you think you can do this before you do that, things kind of go south sometimes, all right? So we took in care of our parentheses, right? We're on this row now. There's no more parentheses. But what's the next letter in PEMDAS? E. What's that stand for? Exponent. Look what we have over there. A 4 cubed. So over here I'm going to do 4 cubed because I don't know what it is. What is 4 cubed? 4 times 4 times 4. How do I do this? I do 4 times 4 and I get 16, but I still need to multiply it by that 1 4. it is 64, okay? Say you don't know that, you come over here and you do 16 times 4, which we already did with 64 up there, right? Didn't we do that up there? Up there, okay. So what does that mean? I'm going to write this whole expression, 36 divided by 12 plus 64 minus 6. Because that was the operation I concentrated on, just the 4 cubed. It's the only thing I did. So everything else stays the same. All right, so now we're down to 3 operations, division, addition, subtraction. Which one are we going to do next? Division, okay? Some of you are comfortable with your 12's times table, and you know right off the bat what 36 divided by 12 is. It's 3. Say you don't know it, do 12 times 2, 24. Maybe I can get closer. 12 times 3, 36. Perfect, okay? So if you don't know that right off the bat, feel free to do scratch work and get powers or multiples of 12 going on over here, okay? So this is 3 plus 64 minus 6. I have addition and subtraction left. They're tied, so what do? Left to right. So what is 3 plus 64? 67. And then 67 minus 6? 61. If you need to line that up vertically, line it up over here. Usually adding a single digit that doesn't carry over, a lot of us can kind of just do in our head, right? Just add the 3 to the 4, that's a 7. So we have 67 minus 6, and that's kind of the same thing here. We don't need to borrow. We can do 7 minus 6, right? So that is 61. Holy moly. Again, look at that crazy contraption up there. It's a whole nother way to write 61. Pretty impressive. All right. This one I don't think is as complicated, but it is one I wanted to point out because this big fraction bar, this big division bar, guys, is a grouping mechanism. What do I mean by that? It's like parentheses. So when you see fraction bars, you kind of have to think of, okay, I need to do this first, this second, and I'm going to divide at the very end. Okay? You have to clean up the top completely, clean up the bottom completely, and at the very end, you're going to divide, okay? So kind of just treat them as 2 separate problems, really, okay? Let's just focus on the numerator. Let's focus on the top. 7 minus 2 times 3 plus 3 squared. No parentheses there, right? So we're going to jump to e exponent. Does everybody agree that 3 squared is our exponent? And 3 squared means 3 times 3. What's 3 times 3? 9. So I'm going to rewrite this as 7 minus 2 times 3, but now I can put something in for 3 squared. I know it's 9. What do we need to do next, guys?
Multiplication.
The multiplication, right? So as much as you want to move left to right, this multiplication in the middle says, hey, I need to happen before you subtract and you add. So what is 2 times 3? 6. So we're going to rewrite this sentence, but we're going to write 6 right in the middle, okay? So this is 7 minus 6 plus 9. Is that okay so far? Addition and subtraction are left. Notice subtraction is first, though, and it kind of goes against what you want to do because PEMDAS, you think subtraction is supposed to be last. No, they're tied. So when addition and subtraction are left, just move left to right, okay? What's 7 minus 6? 1. What's 1 plus 9? 10. So what does that mean? It means we can come up here, guys, and write 10 on top. We did all the top, and we got 10. The bottom will go a little bit quicker. It's not as in-depth, okay? Some of you can kind of look at it right off the bat and know what it is, and that's fine, okay? So let's do the bottom. It's 5 times 2 minus 1. When it comes to doing operations, parentheses should be calling at you, do me first, please. It's like my 5-year-old daughter, me first. Like she can't wait for her 2-year-old sister, all right? So what are we going to do first? That guy. What's 2 minus 1? 1. What operation, this is something that I kind of failed you, I feel like, on Tuesday. I didn't really point out. What operation is this when you have a number and you have parentheses there? That is multiplication, okay? Anytime you have things shoved right next to each other with no symbol, it's multiplication, okay? So I'm going to rewrite this as 5 times, what did we say the parenthesis was? 1? Is that okay, guys? And then what's 1 times anything? That number. So that's just 5. Wasn't that a little bit easier than the top? Okay. So guess what we can go do now? We now know the bottom number. So this first one cleaned up to 10. The bottom number cleaned up to 5. And remember, this fraction bar is another way to show division. What's 10 divided by 5? How many times does 5 go into 10? 2 times. Don't know it? You know 5 times 1 is 5. But 5 plus 5 twice is 10. So your answer is 2. 2 is such a simple number. Look how they complicated it, right? It's pretty impressive. All right, let's look at this last page here, guys. Yeah, it is awesome, okay? This one really is not that bad. How about you guys try to do that without me? Think about which one you need to do first, which one you need to do second, which one you need to do third. Is this one where you can go left to right? It is, isn't it? So you're going to do 64 divided by 8 first. Again, if you don't know that off the bat, do a couple multiples of 8 off to the side and see how close you can get to 64. With order of operations, most of the time it's going to be perfect numbers, okay? When they have you do these divisions, there's not going to be remainders, all right? Okay, will you raise your hand before you leave so you can grab that? And then, do you guys talk to each other outside of class so she can let you know what part of the worksheet? Okay. Once you get 64 divided by 8, the next thing you need to do with that answer is double it, times it by 2. And at the very end, you add 4, okay? And you're going to quickly see with this class why it's really important to know your times table. So it's one of those things that if you're not comfortable with powers of 8 and 9, maybe practice them, even if it's flashcards. I know that's old school, but the easier and quicker you can get those, it makes just the rest of these problems not seem as scary because you know, oh, 8 goes into 64, how many times? 8 times, right? So this is 8 times 2 plus 4. Is that what you guys got? And then I need to do multiplication next. What's 8 times 2? 16 plus 4. And what's 16 plus 4? 20. Did you guys get 20? Woohoo! Okay, last thing real quick, and if it cuts me off, I'm not too worried about it. Area of a square is just a special rectangle, okay? So what was the area of a rectangle? Length times width, base times height, right? Why is this in this section? Because what do we know about a square? What's so special about a square? All the sides are equal. So really the area of the square is technically s squared. We didn't know about exponents before. Now we do, so now they can give you this formula. I don't memorize that. I just say it's a special rectangle, base times width, length times width, base times height. I don't care, okay? So guys, the area is just going to be 9 times 9, or what? 9 squared, which is 81. And then what are we going to do with our units? Centimeters squared. Thank you for saying centimeters squared, because that's something that I noticed on that worksheet. You guys had that unit, but a lot of you forget the square. Perimeter is just a linear length. You're just adding how much feet you have, so that's why it's just feet. Area, it's a bunch of little squares. You could cut this up into 9 squares, cut this up into 9 squares. Say that's a brownie pan, okay? We have 81, those are going to be small brownies, but we have 81 brownies in there, so we have squares, okay?